Okay, so that's going to equal x plus 4 times x minus 3 all over x minus 2, x minus 5. Okay, so it's a little bit longer than the ones before. Okay, so that's just our numerator. Okay, so now we have to do the same thing with our denominator. And, try to scroll up enough to where you can still. Okay, so for our denominator, you're going to have 3 over x minus 6 minus 2 over x minus 5. Okay, so if we're going to rewrite that one, give it a little bit of space. We multiply this one by x minus 5 over x minus 5. Okay. And we multiply this one by x minus 6 over x minus 6. Okay. So now we have our matching denominators. Okay. So we have 3 times x minus 5 over x minus 5 times x minus 6. Minus 2 times x minus 6 over x minus 5 times x minus 6. Okay, so we have our matching denominators, which means our answer is going to be something over x minus 5 times x minus 6. I'll write it underneath. So x minus 5, oops, scanned it up, sorry about that, times x minus 6. Okay, so here you have 3 times x minus 5 minus 2 times x minus 6. All right. So from here, we just go ahead and distribute those. Get up a little bit. Okay, so that would give us 3 times x is 3x. 3 times negative 5 is negative 15. Negative 2 times x is negative 2x. Negative 2 times negative 6 is positive 12. All over x minus 5 times x minus 6. Told you, step 1 is usually the one that drains you the most. Yes?
Plus 12.
Oh, when you distribute the negative 2 and the minus 6. Okay, so now we do just like we did before, we combine our like terms. Okay, so we can actually combine 3x and 2x, and we can combine negative 15 and positive 12. Okay, so 3x minus 2x is just x. And negative 15 plus 12 is minus 3. All over x minus 5 times x minus 6. Okay, so this is our new denominator. Okay, so we have our single fraction for our numerator. Let me bring that down a little bit. And we have our single fraction for our denominator. I already know this is not going to fit on this one page. And actually, you don't have to. It usually won't take you this long. I'm just doing like the step by step. Most people, when they're doing this one, they don't rewrite it. They just go right to that step. So if you went right to that step, it would be a lot shorter. But this is mainly for the benefit of looking at the notes later. just have to continue. I'm going to continue that on the next sheet. All right. Let me write down where I left off. So x plus 4, x minus 3. Oh, actually, let me just go ahead and continue from there. Okay, so that means our 6 over x minus 5 plus x over x minus 2 divided by 3 over x minus 6 minus 2 over x minus 5 becomes our numerator, which is x plus 4 over x minus 3 divided by x minus 2 over x minus 5 divided by, and we figured out our denominator, is x minus 3 over x minus 5 times x minus 6. Okay, so step 1 is done. Step 2 and 3 are the downhill versions of this because you're just canceling. Well, you're rewriting, then you're canceling. Okay, so our second step, make a little bit of a barrier. Here we go. Okay, so your second step is you're going to rewrite it and cancel stuff out. Okay, so that means your x plus 4 times x minus 3 divided by x minus 2 times x minus 5. And instead of drawing that as a fraction, you just make it divided by x minus 3 over x minus 5 times x minus 6. Okay, so if you're dividing your fractions, you just have x minus 4, or x plus 4, over x minus 3, over x minus 2 times x minus 5. Your division changes to multiplication. You flip your second one. Over x minus 3. Okay, so now is where you can start. You can either cancel it out here, you can make it as one fraction. Either one would still work. So if you decided to cancel out here, you have x minus 5 canceling with that x minus 5. You have this x minus 3 canceling with that x minus 3. Okay, so there's really nothing else that will cancel out. So you end up with x plus 4 times x minus 6 over x minus 2. And you don't have to FOIL method that or anything. This should be enough. Okay, so any questions on this one? All right. Like I said, it normally doesn't take this long, but because I'm doing step by step by step by step and rewriting a lot of extra stuff, it seems a lot longer than it really will be. But once you get used to it, you'll skip your own steps and find the fastest way for you. Right. Okay, so let's say now we're going to start on solving rational equations. Okay, so the steps for this one. Okay, so your first step is you're going to factor the numerator and denominator, if you have to. And that's one of those if necessary kind of things. Numerators and denominators. Okay, so the next thing you want to do is you want to get all of the fractions to have the same denominator. Okay, now that means on both sides of the equal sign, because if you have the same denominator on both sides of the equal sign, they actually cancel out and they disappear. So they can be, I guess you can say, eliminated or okay. So really, this second step will get rid of the fractions. So every fraction should disappear after this second step. Okay. So third, remove any grouping symbols like your parentheses or anything else, and from there you can just solve it. Okay, so for example, parentheses. And solve the equation. Okay, so now the fourth step is pretty important because a lot of people tend to forget it. Is you want to check your answers by plugging them into the original equation and making sure that your denominator won't equal 0 for any of them. Now, you don't have to find the answer for all of them. You just want to make sure that if you have two answers, that one of those answers or both of them don't give you a denominator of 0. Check your solutions by plugging them into the original equation to make sure the denominators do not equal 0. Oops, sorry about that. Okay, I think everyone's done. Okay, so let's say, for example, if we wanted to solve x divided by 6 plus 4x divided by 3 equals x divided by 18. Okay, so your solution to that, remember your first step, you want to factor your numerators and denominators if necessary. Here you don't really have to because x is already factored, 4 times x is already factored. You can make it 2 times 2 if you want, you don't have to. X is factored here. You can make that 6 times 3 if you want, but you don't have to, so it's not really necessary. Okay, so factoring is not necessary. Okay, so remember your second step is you're going to make sure all of your denominators match. Okay, so you're going to match your denominators. Okay, so if you have x divided by 6 plus 4x divided by 3 equals x over 18, you can rewrite that, give it a little bit of space, x over 6 plus 4x over 3, give it a little space, equals x over 18. You can turn 6 and 3 into 18. Okay, so if you multiply 6 times 3, you can make it 18. If you multiply 3 times 6, you can make it 18. And 18 is already 18, so you don't have to do anything with that one. Okay, so 3 times x will give you 3x over 6, well, 3 times 6, which is 18, plus 4x times 6, 6 times 4 is 24, so you have 24x over 3 times 6, which is 18, equals x over 18. Okay. Now, if you multiply each one of those terms by 18, so multiply each term by the denominator. Okay. So here your denominator is 18, so you multiply each one by 18. So you have 18, or you can make it 18 over 1 if you want to. I usually make it 18 over 1. Times 3x over 18 plus, oh, sorry about that, 18 over 1 times 24x over 18 equals 18 over 1 times x over 18. Okay. Now really, once you have the same denominator on both sides of the equal sign, you can skip this step if you want to, but this is just showing you how it works. Okay, so this 18 will cancel with that 18. This 18 will cancel with that 18. And this 18 will cancel out with that 18. So really, after the second step, all fractions should disappear. Okay, so you have 3x times 1, which is 3x over 1. 3x over 1 is just 3x. 24x times 1 is 24x. Divided by 1 is just 24x. Equals x times 1 is just x divided by 1, so you just have x. Okay, so once you get the same denominator and you multiply each one of those terms by that denominator, they'll always cancel out. So now only thing left will be just the numerator. Okay. Any questions on that step? All right. Okay. So now you just simplify it or solve it. Okay. So third step, you solve it. Okay. So really you can just combine those two. So you have 3x plus 24x is 27x. Equals x. Here, if you subtract x from both sides, you have 26x equals 0. You divide both sides by 26. 0 divided by anything is just going to be 0. So here you have x equals 0. Oh, sorry about that. Okay. And your fourth step, you don't really have to plug it in. But if you look back up to your original equation, x over 6 plus 4x over 3 equals x over 18. Plugging x equals 0 in will not make any of those denominators equal 0. So as long as no denominators will equal 0, you're okay. Oops, so x equals 0 is a solution. All right, so any questions on that one? All right. I'll leave that up for a few. All right. Okay, so what if we had, next example, if we wanted to solve five plus 4 over x equals 1. Okay. So again, with this one, you don't really need step 1. We'll need step 1 in later examples. But for this one, you don't need step 1 because everything is pretty much factored. Oh, let me close this up. Okay, so the first step, factoring isn't necessary. Okay, so your second step, you want to match all of your denominators. Uh-oh. Okay. So the thing is with 5, when you get just a number, you can make 5 equal anything. So just a quick little note that 5, you can make that equal 5x over x. Okay. So that's, when you have just a number, you can make that equal anything. Okay, so if you have 5 plus 4 over x equal 1. Oh, actually, I should have put and 1 can equal x over x. Okay, so we can make that become 5x over x plus 4 over x equals x over x. Okay, and just like we did before, like I said, this step here, you can skip it if you want to, because once the denominators match both sides of the equal sign, they're going to disappear anyway. Okay, so you're going to multiply each term by the denominator. Okay, like I said, this step is strictly optional. Okay, so you have, instead of x, we'll have x over 1 times, oh, actually, we didn't need to do that on that one, but 5x over x plus x over 1 times 4 over x equals x over 1 times x over x. Okay, so we see here, this x cancels out, these two x's cancel out, and these two x's cancel out. So we're left with 5x times 1 is just 5x. Actually, when those cancel out, they become 1. Let me put that there. So 5x times 1 is 5x over 1, so that's 5x plus 4 equals x. Okay, and now we just solve for x. Okay, so if we solve for x, we can just subtract x from both sides if you want to. So 5x plus 4 equals x. So we subtract x from both sides. X minus x is 0. Okay, and we end up with 5x minus x is 4x plus 4 equals 0. So if we subtract 4 from both sides, 4 minus 4 is 0. We have 4x equals negative 4. Okay, so now we just divide both sides by 4. Okay, anything divided by itself is just equal to 1. So we have x equal negative 4 divided by 4 is just negative 1. Okay. And for your fourth step, like I said, you don't have to plug it in and solve it and everything else. You just want to make sure no denominators will equal 0. Okay, so we'll do our fourth step in a little box over here. Remember, that's just your check. 5 plus 4 over x equals negative 1. Denominator does not equal 0. When x equals negative 1 is plugged in. Okay, so that means x equal to negative 1 is a solution. All right, so any questions on that one?